You think you know what time is. You look at a clock, you feel yourself aging. You remember the past but not the future. So you think time flows like a river, carrying you from yesterday through today and into tomorrow. But that's not time. That's just a sensation, a biological illusion. And when you look at what actually happens at the quantum level, when you watch what electrons really do, your entire concept of time collapses. Here's what they don't teach you in school. At the quantum scale, time doesn't flow. The past and future blur together. An electron can be influenced by measurements you haven't made yet. The arrow of time, that comfortable feeling that the past is fixed and the future is open, it breaks down completely. And this isn't philosophy. This isn't interpretation. This is measurable, experimental fact. Let me prove it to you. Let me show you how the universe destroys your concept of time the moment you look closely enough. Start with something simple, the double-slit experiment. You have a wall with two slits. Behind it, a screen that detects particles. You fire electrons at the wall one at a time. Each electron is a discrete event. You can time stamp it. Electron 1 at t equals 0. Electron 2 at t equals 1. Electron 3 at t equals 2. You're creating a sequence, a timeline. This happened, then that happened. Past, present, future. Time flowing forward, one event after another. But here's where your timeline shatters. These electrons, sent one at a time with clear timestamps, separated by intervals of time, somehow interfere with themselves. Each electron creates a pattern as if it went through both slits at once, but you sent them separately. One electron exists at time t. The next electron exists at time t plus 1. They're separated by time itself. How can they interfere? The answer is going to break your brain. The electron doesn't go through the left slit at time t and the right slit at time t plus 1. Before you measure it, the electron doesn't exist in time the way you think of time. It exists in superposition. Both paths, both times, simultaneously. The electron doesn't have a history until you force it to have one. Think about what that means. You assume the past is fixed. The electron went through one slit or the other at a specific moment. That moment is gone now, frozen in the past, unchangeable. But that's wrong. Before measurement, there is no past. There is no specific moment when the electron was at a specific place. There are only probabilities spread across space and time. When you put detectors at the slits, when you try to record which slit the electron went through and when, the interference pattern vanishes. By measuring, by creating a record, by trying to establish a timeline, you destroy the quantum behavior. You force the electron to pick a history. You force time to flow. Before measurement, there is no definite when, only possibility. This is not speculation. This is what happens in laboratories. Measurement creates history. Before measurement, the past is not fixed. It is probability, quantum foam. And the act of looking, of recording, of creating a timestamp forces reality to pick one past out of many possible pasts. But it gets worse. Much worse. There's something called the delayed choice experiment, and it's going to destroy whatever's left of your intuition about time. Here's how it works. You send a photon, a particle of light, through a similar setup. Two paths it can take. You can choose whether to measure which path it took or let it interfere. Normal quantum mechanics, right? Except you make the choice after the photon has already gone through. The photon passed the decision point in the past. It should have already decided whether to behave like a particle or a wave. Past tense, already done. History written. But when you make your measurement choice in the present, you retroactively determine what the photon did in the past. Your choice now changes what happened then. This has been done in laboratories, with photons separated by vast distances. They sent a photon on a journey, waited until it had traveled far enough that by all classical reasoning it had already committed to one path or the other, and then made the measurement choice. And the photon's past behavior changed depending on what measurement they chose to make in the present. The photon's history is not written until you write it. The past is not fixed. It is probability, and measurement collapses that probability, not just in space but in time. Your present choices retroactively determine past events. Cause and effect, the most fundamental assumption you have about time, breaks down at the quantum level. You want to protest. You want to say the photon must have done something specific in the past, we just didn't know what. That's the hidden variable hypothesis. Einstein believed it. A lot of very smart people believed it, and they were wrong. Completely, demonstrably, experimentally wrong. John Bell proved that if particles carried hidden information about their past states, certain measurements would have to produce certain results. We did those experiments. Nature violated Bell's inequalities. The particles genuinely do not have definite past states. The past is not determined until you measure it. Time at the quantum level does not work the way your brain thinks it works. Now let's talk about the uncertainty principle, because this is where time really gets strange. You know you can't measure both position and momentum precisely. The more you know about where something is, the less you know about where it's going. Position and momentum are incompatible. The universe will not give you both pieces of information. But there's another uncertainty principle that nobody talks about: energy and time. The more precisely you know when something happened, the less precisely you can know its energy. And vice versa. This is not about measurement error. This is fundamental. Time and energy are conjugate variables, just like position and momentum. What does this mean? It means if you try to measure the exact energy of a particle, the time becomes fuzzy. The when becomes undefined. The particle exists in a smear of time, just like it exists in a smear of space. And if you measure the exact time, the energy becomes undefined. This gets really weird when you think about very short time scales. At time scales shorter than Planck time, about 10 to the minus 43 seconds, the uncertainty in energy becomes so large that particles can spontaneously pop into and out of existence. The vacuum isn't empty. It's seething with particles that exist for immeasurably short moments, borrowing energy from the uncertainty principle, then vanishing again. These aren't hypothetical particles. We've measured them. They affect real experiments. The Casimir effect, the Lamb shift. All these phenomena come from particles that exist in the gaps of time too small for time itself to be well defined. At the shortest scales, time dissolves into quantum foam. There is no continuous flow, just probability. Let's go back to that comfortable lie you tell yourself. You think time is a container, a stage on which events happen. The universe is a box, and time is a clock on the wall, ticking away even if the box is empty. You think if we removed every particle, every bit of energy, time would still tick, 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 tick. Wrong. Time is a measure of change. If nothing in the universe changes, time stops having meaning. You can't define a second without a physical process to mark it, an atom oscillating, light traveling, something happening. Time is not separate from events. Time is the ordering of events. And at the quantum level, before measurement, events are not ordered. They exist in superposition. Multiple timelines, multiple histories, all simultaneously real until measurement forces them to collapse into one definite sequence. The past is not a fixed line stretching behind you. The past is probability amplitude, and measurement is what makes it real. Consider the Schrödinger equation. It describes how quantum wave functions evolve in time. And here's the thing about the Schrödinger equation. It's perfectly reversible. You can run it forwards or backwards. There is no arrow of time in the equation itself. The quantum world doesn't care about past versus future. Both directions are equally valid. The arrow of time only emerges when you measure. When the wave function collapses, that collapse is irreversible. You can't uncollapse a wave function. You can't unring that bell. And this is where the arrow of time comes from, not from the quantum equations themselves, but from the act of measurement, from the interaction between the quantum world and the classical world. What does that mean? It means the flow of time. The thing you experience as the universe marching from past to future is not a property of the universe itself. It's a property of observation, of measurement, of conscious systems interacting with quantum systems and forcing them to pick definite outcomes. Before measurement, the quantum world exists in a timeless superposition. All possible pasts and futures coexist. Measurement is what creates time, what creates history, what separates the past from the future. Time doesn't flow. Time is what happens when you look. And this brings us to entanglement, because this is where things get truly insane. You can create two particles in such a way that their properties are linked. Entangled. You separate them by any distance. Kilometers, light years, doesn't matter. Now you measure one particle. Instantly, faster than light could possibly travel, the other particle snaps into a correlated state. Einstein hated this. He called it spooky action at a distance. He said it violated relativity, which says nothing can travel faster than light. But here's the thing Einstein missed. The correlation doesn't travel. It doesn't propagate through space over time. It just is. The two particles share a single quantum state, a single wave function that exists outside of space-time until you measure it. When you measure one particle, you're not sending a signal to the other particle. You're collapsing a wave function that contains both particles. And wave function collapse doesn't happen in time. It's instantaneous. Not fast. Instantaneous. Zero time elapsed. Because it's not a process happening within space-time. It's the creation of space-time. Before measurement, the two particles don't have separate states. They share one state, one wave function, one reality. And that reality exists in a quantum realm where space and time are not yet defined. Measurement forces that quantum realm to pick classical values, to create definite positions and definite moments, to create space and time. Think about what this means for your concept of now. You think there's a universal now, a present moment that exists everywhere in the universe simultaneously. But entanglement proves that's wrong. When you measure an entangled particle here, the other particle light years away instantly becomes defined. There's no light speed delay. The correlation is immediate. How can that be if there's a universal flow of time? If time is a river flowing at the same rate everywhere? It can't. The only way entanglement makes sense is if, at the quantum level, there is no universal now. Different observers, different measurements create different timelines, different pasts, different presents. This is where relativity and quantum mechanics meet, and it's where both theories start to break. Relativity says simultaneity is relative. What you consider to be happening now depends on how fast you're moving. Quantum mechanics says the past is not fixed until you measure it. Put them together, and you get a universe where time is not a thing that exists independently. Time is a relation, a perspective, a consequence of observation. You are not moving through time. You are creating time with every observation, every measurement, every interaction between your quantum mechanical brain and the quantum mechanical universe around you. The past you remember is not a fixed record. It's a wave function that collapsed when you formed the memory. The future you anticipate is a superposition of possibilities that hasn't collapsed yet. Let's bring this back to where we started. You count seconds in your head. You think you're tracking time. But what you're really doing is running an internal quantum process. Neurons firing, ions crossing membranes, molecules changing state. All of it governed by quantum mechanics. All of it creating a subjective experience of duration that has nothing to do with some universal time flowing past you. Different people count time differently. Some people subvocalize, some people visualize, some people use completely different neural machinery, and all of them think they're measuring the same thing. But they're not. They're each creating their own personal timeline, their own sequence of collapsed wave functions, their own subjective experience of duration. There is no master clock ticking in the background of the cosmos. There is no universal now that synchronizes all observers. There are only quantum wave functions evolving according to the Schrödinger equation, and measurements collapsing those wave functions into definite events, creating the illusion of a timeline. And here's the really disturbing part. If time is created by measurement, by observation, by conscious systems collapsing wave functions, then what happened before there were conscious observers? What was time doing before there were brains to measure it? The answer might be nothing. Time might not have existed in any meaningful sense before there were systems capable of making measurements. The early universe, hot and dense and completely quantum, might have existed in a timeless superposition. No past, no future, just probability amplitude, only when the universe cooled enough for stable structures to form, for atoms to exist, for planets to coalesce, for life to evolve, for brains to develop, only then did measurement begin to happen on a large scale. Only then did wave functions start collapsing. Only then did time begin to flow. This is speculation, of course, we don't know, but the equations suggest it. Quantum mechanics says the past is not fixed until it's measured. Cosmology says the early universe was pure quantum mechanics. Put them together and you get the possibility that the past is still not entirely fixed, that the Big Bang itself might still be in superposition, waiting for some final measurement to determine exactly how it happened. You think the past is solid. You think it's written in stone, unchangeable, done. But at the quantum level, the past is fluid, probability, and measurement is what solidifies it, what turns possibility into history, what creates the timeline you experience as the flow of time. So when you ask, what is time? The answer is this. Time is not a thing that exists independently of events. Time is not a container or a stage or a river. Time is the collapse of quantum wave functions. Time is what happens when possibility becomes actuality. Time is measurement. And the flow of time, that feeling of being carried from past to future, is just your brain registering the continuous collapse of quantum wave functions around you and inside you. Every moment, billions of quantum events collapse. Every moment, possibility becomes history. Every moment, you create a new slice of past and a new set of possible futures. You are not a passive observer watching time flow. You are an active participant creating time with every observation. Every thought is a measurement. Every perception is a wave function collapse. Every memory is a solidification of probability into definite past events. Time doesn't carry you. You create time. And the universe, at its most fundamental level, exists in a timeless quantum state, waiting for observers like you to measure it, collapse it, and force it to pick a timeline. This is what quantum mechanics tells us. Not that time is an illusion, but that time is emergent. It's not fundamental. It's what happens when fundamental quantum processes interact with complex systems capable of observation. You think time is the most basic thing in the universe, but time is actually one of the most complicated things. A consequence, not a cause. An effect, not a foundation. And if that makes you uncomfortable, if it violates everything you thought you knew about past and future and cause and effect, good. Your discomfort means you're starting to understand. The universe is not obligated to make sense to the pattern-matching machinery in your brain. The universe just is. And time, real time, quantum time, is far stranger than the simple flow you experience in your everyday life. So the next time you look at a clock, remember what you're actually seeing. Not time itself, but a human-made device designed to help you coordinate with other humans. Not the flow of the universe, but a convenient fiction that lets you schedule meetings and catch trains and organize your life. Real time, quantum time, is happening at a level your consciousness can't directly access. It's wave functions collapsing. It's probabilities becoming actualities. It's the past being created moment by moment through the act of observation. It's the future remaining in superposition until measurement forces it to pick a path. You live in the quantum foam. You swim in the collapse of wave functions. And the timeline you experience, the comfortable march from past through present to future, is just the wake you leave behind as you navigate through an ocean of probability. Time is not the water. Time is the wake. And you, with every observation, every thought, every moment of consciousness, you are the boat creating it. Let's go deeper. Because there's an experiment that makes this even more concrete. It's called the quantum eraser, and it demonstrates that you can literally erase the past, change history, make things that already happened unhappen. Here's the setup. You run the double-slit experiment, but you mark which slit each photon goes through. You create a record, a past. The photon went through the left slit at time t. That's history now. Done. Fixed. The interference pattern disappears because you've established a definite timeline. But now, before you look at the final screen, you erase the which path information. You destroy the record of which slit the photon went through. You delete the past. And when you do this, the interference pattern comes back.
The photon retroactively went through both slits. The past changes because you erase the information about it. This has been done, not theoretically, actually done in laboratories. You can change what happened in the past by erasing information about it in the present. The past is not solid. The past is information, and information can be created or destroyed, which means the past can be created or destroyed. Think about what this means for your life. Every memory you have is information stored in the configuration of neurons in your brain. Quantum mechanical neurons. Quantum mechanical synapses. The past you remember exists because there's a physical record of it in your brain. But if that record were destroyed, if those neural connections were severed, that past would cease to exist in any meaningful sense.
You might say, but the events still happened whether I remember them or not. Did they? According to quantum mechanics, events without records, without measurement, without collapsed wave functions don't have definite states. They exist in superposition. The breakfast you don't remember might be in superposition between having happened and not having happened. The record is what makes it real. This is not solipsism. This is not saying reality doesn't exist without you observing it. It's saying that definite classical reality, the world of objects at definite places at definite times, emerges from quantum mechanics through the process of decoherence and measurement. And without measurement, without records, there is no definite classical past. Now think about the universe as a whole, cosmology, the Big Bang. We have records. We have the cosmic microwave background radiation, a snapshot of the universe 380,000 years after the Big Bang. We have the relative abundances of light elements. We have the large-scale structure of galaxies. These are measurements, records. They collapse the quantum state of the early universe into a definite history. But what about events that left no records? Quantum fluctuations in the early universe that didn't leave traces in the cosmic microwave background. Do those events have a definite past, or are they still in superposition, multiple histories coexisting because there's nothing to collapse them? The equations of quantum cosmology suggest that the entire universe might be described by a single cosmic wave function. This wave function evolves, but it doesn't collapse unless something measures it. But what measures the universe? There's nothing outside the universe to observe it. So maybe the cosmic wave function never fully collapses. Maybe the universe exists in a superposition of all possible histories simultaneously. This is the many worlds interpretation, not science fiction, a serious interpretation of quantum mechanics proposed by Hugh Everett. The idea is that the wave function never collapses. Every possible outcome of every quantum measurement actually happens, but in different branches of reality. The universe constantly splits into multiple timelines, one for each possible outcome. You measure an electron's position and find it here. In another branch, another you finds it there. Both outcomes happen. Both histories are real. But you can't see the other branches because decoherence prevents them from interfering with each other. You're stuck on one branch of the timeline, experiencing one history out of countless histories that all exist simultaneously. Is this true? We don't know. The math works. The predictions are identical to standard quantum mechanics, but it implies an infinity of parallel timelines, all equally real, all diverging with every quantum event. Your past is one path through an infinite tree of possibilities, and every other path also exists, also has a version of you, also is equally real. This is where quantum mechanics takes the concept of time and explodes it. Time is not one line, time is a branching tree, or maybe a graph, or maybe something even more complex that we don't have the mathematics to describe yet. Every moment contains infinite possible futures, and according to many worlds, all of them happen, but you only experience one. Why? We don't know. The measurement problem, the problem of why your consciousness experiences one outcome instead of existing in superposition across all outcomes, is unsolved. Some people think consciousness itself plays a role in wave function collapse. Some think consciousness is irrelevant and it's just about decoherence. Some think the question doesn't even make sense. What we do know is this. Your experience of time as a single line from past to future is not how quantum mechanics describes reality.
Quantum mechanics describes a space of possibilities that branches or superposes or does something we don't have good words for. And measurement, observation, the creation of records is what picks out one path through that space. Think about your own timeline. Right now, you're reading this. That's a measurement, an observation, a collapse of quantum wave functions in your brain. This moment is becoming part of your past. But somewhere in your brain, there are quantum processes that haven't collapsed yet. Neurons in superposition, synaptic states that exist in multiple configurations simultaneously. Those uncollapsed quantum states don't have a definite past yet. The firing pattern that led to them is still in superposition. Your own recent history at the quantum level is not entirely determined. It's still fluid, still probability. And the next measurement, the next thought, the next conscious moment will collapse some of that superposition and create more definite past. You are constantly creating your own past, not in a metaphorical sense, literally. Your brain is a quantum system, and consciousness involves the continuous collapse of quantum states. Every moment of awareness is a measurement that solidifies some probabilities into definite past events while leaving others still open, still in superposition, still waiting for future measurements to determine what really happened. This is why memory is unreliable, why two people remember the same event differently. It's not just psychology, it's quantum mechanics. The past you remember is the past your brain has constructed through a series of quantum measurements. Someone else's brain, making different measurements, collapses different wave functions and constructs a different past. Both are real, both are valid measurements. The objective past, independent of observation, might not exist. And this applies to history in general. We think history is fixed. We think what happened in 1776 or 1492 or 10,000 BCE is solid, unchangeable, done. But all we have are records, artifacts, measurements, and those measurements are what collapse the wave function of historical events into definite states. Events that left no records have no definite state. They remain in quantum superposition, multiple histories coexisting until something measures them. Could new evidence change what actually happened in the past? Not change our knowledge of it, but change what actually occurred? According to quantum mechanics, maybe. If an event left no records and exists in superposition, new measurements could collapse it into one history or another. The past would literally be created by present measurements. This sounds insane. It feels wrong. Your intuition rebels against it. But your intuition was shaped by classical physics, by a world where time flows in one direction and the past is fixed. Your intuition is wrong. The universe is quantum. And in a quantum universe, time is not what you think it is. So what is time? Time is the bookkeeping system we use to order measurements. Time is what happens when wave functions collapse. Time is the dimension along which entropy increases, along which records accumulate, along which the tree of possible futures branches into definite past. But time is not fundamental. Time is emergent, a consequence of quantum mechanics, not a prerequisite. And the flow of time, the sensation that you're moving from past to future, is your brain's interpretation of the continuous collapse of quantum wave functions. Your neurons are quantum mechanical. Your thoughts are measurements. Your consciousness is the process of collapsing quantum superpositions into definite states. You don't experience time, you create it. This is the deep truth that quantum mechanics reveals. The universe is not a clockwork machine ticking away in an absolute time. The universe is a quantum system evolving in a timeless way until observation forces it to pick classical values, to choose definite positions and moments in histories. Time emerges from this process. Time is what observation creates. You are not in time. Time is in you. Every measurement you make, every observation, every thought adds another slice to your personal timeline, and that timeline is yours alone. Other observers create other timelines. The universe doesn't have one timeline. It has as many timelines as there are observers making measurements. And at the foundation, beneath all the timelines, the quantum realm is timeless. The Schrödinger equation evolves wave functions, but it doesn't care about before and after. It's reversible, time-symmetric. The arrow of time only appears when you introduce measurement. when you force the quantum system to interact with a classical observer and collapse into definite states. This is quantum mechanics. This is how time actually works at the most fundamental level we can probe. Not a river, not a flow, not an absolute background, but an emergent property of observation, of measurement, of the continuous collapse of possibility into actuality. Time, real time, quantum time, is so far beyond everyday intuition that understanding it requires abandoning almost everything you think you know about past, present, and future. That's the cost of understanding the universe. Giving up the comfortable lies for the uncomfortable truth. And the truth is this: time is quantum, time is measurement, time is you.